Now we'll be looking at how we can use parentheses in much the same way that we did with algebra to split up these symbols, this logical statement notation that we're looking at here. So best way to do that, best way to think about it is with examples. Let's start by looking at the statement E is day destroys the night, and Q is night divides the day, where our goal is to write out the symbolically represented statements as given. So, here, for the first one, if we want to write not E and Q, this means we want to take the statement E and Q and hate it. So, this would be just saying it is not true. Whenever we have a negation on the outside of parentheses, we can always just toss and it is not true at the front of our sentence and we get what we need. But we can say here, it is not true that day destroys the night. And night divides the day. But remember, day destroys the night is the statement P. You got that conjunction and then we have Q. Q is night divides the day. For our second statement, we have not P and Q. So, not P would be something to the effect of day doesn't destroy the night. Q is still just Q, night divides the day, which means one way that we can write this is day does not destroy the night. And night divides the day. This is a lot like what we did with the set theory stuff in chapter 2. A matter of carefully going through these symbols and understanding what they mean. Again, we're learning a notation as much as anything. And so for our last case, we have not P or Q. What we want to do here is think about what P or Q could be read as. That would be day destroys the night or night divides the day, where if we negate that, we could turn that into something in a couple of different ways, but the easiest way that we could maybe do that is day does not destroy the night. And night does not divide the day. This type of thing here, where we're negating a group, works a lot like the Morgan's laws did when we were talking about set theory. So we could take P or Q. If you negate the whole thing, it becomes not P and not Q. Another way that we could write this, if we want to be a bit more literal, is it is not true that day destroys the night or night divides the day. That would be following a it is not type of argument. It means if we wanted to talk about this one again, we could alternatively say it as day does not destroy the night or night does not divide the day. There are usually and just about always little options for how we can represent something like this, how we can write out the sentence if we want to do it carefully, that get to the same place. Now, let's take a look at another example. Here we're given the statements E, there is smog, Q, the dogs do not bark, and R, today is a good day, where we want to turn the symbolic statements if Q and not P, then R, and Q and not P implies R. second one's a little hard to read. And I'll also say here that technically R is more of an opinion than a statement generally, but for the sake of this example, I'm going to cede to Ice Cube's definition of good day. Anyway, here, what we do is group the parentheses with commas. That is to say, if things are paired off in parentheses, then we separate the sentence that we write out for the compound statement using commas. So for that first one, we can say that for Q and not, we're going to not worry about R for just a second. This can be read as if the dogs do not bark, because we're accepting Q at face value. And the opposite of there is smog is there is no smog. So if the dogs do not bark and there is not smog, I'll just say imperfect grammar, there is no smog. Then day is a good day. On the other hand, if we have first, Q and not P implies R, be a little bit more careful with the spacing here. We would say the dogs do not bark. It's just an assumed statement, and then since we have the parenthesis, we put in a comma. And then we go into that conditional, where we say, and if there is no smog, then day is a good day.